Hello, everyone. Hopefully, you're doing well. We're going to continue with chapter 3, graphing. We're still doing intermediate algebra. In the previous sections, we went over graphing equations, introduction to functions. If for some reasons you missed these two, I strongly advise you to go back and watch those videos that I posted previously. In this video, we would focus on section 3.3, graphing linear functions. So one of the things you need to remember in this video, where we're gonna really talk about graphing linear functions, because in this section we identify and graph linear functions, right? In these sections. We did that at the beginning, especially where we use the vertical line test. So once we use a vertical line test, and if it's intersect the graph only one time, so we know it's a functions. And also, we know that all linear equations, except those graphs that are vertical lines, they are all functions. If you use very linear equations, then you know linear equations is a function. So linear equations is a functions in the form like mx plus b, right? Um, M and B, they are constant. Or you can say y equal ax plus uh, b. I mean, no, 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 no. Or the general form, I would say, if you have ax plus by equals c. So a, b, c's, they are all real numbers. And this is a linear function because there is no power to no, I mean, the exponents are not greater than 1 for x and y, and you don't have any symbols like absolute value or radicals like roots, square roots, cube roots, etc. Now, in this section, we will focus on graphing functions. We started very early, but now we're going to really start with graphing linear functions. And we're going to graph linear functions by using intercepts, and we're going to graph vertical and horizontal lines. Remember, in section 3.1, we went over a few different graphs that are non-linear, like we graph a parabola, we graph an absolute value functions, we graph a radical functions, but here we would focus on linear functions. The first thing you need to remember here, if they ask you to graph g of x equal to x plus 1, and you can compare it with 2x. Now, if you look at this graph, remember I said anytime you said g of x, it's the same thing you say y. So that means if you plug any number for x, when you do g of x, let's graph g of x first. Or let's graph, we're gonna graph f of x. Let's graph f of x. If you graph f of x equal to x, you know it's gonna be a line. So either we said f of x or g of x, still, when anytime you plug a number for x, you obtain y. That means in these functions right here, if x is 0, 2 times 0 would be 0. So you have your first point on the xy plane where, we said 0, 0 is your first point. And now, if you plug x equal 1, 2 times 1, y would be 2. So when x is 1, y is 1 and 2, so y would be 2. So this is the point 1, 2. If x is negative 1, then y would be 2 times negative 1 would be negative 2. We're going to have x negative 1 and y would be negative 1 and negative 2. So we have the points here. I think this is enough. We can use all the other points, but you know what? 3 points is already even too many for us to graph that straight line. We know it's going to be linear. It's a very straight line here. Now, our goal for now is really to graph the g of x. So if I take the g of x equal to x plus 1, we can just, uh, you know, uh, um, you know, shift it 1 unit. So now let me show you how you're gonna shift it. If you don't get it, it's better. When x is 0, 2 times 0 is 0 plus 1 is would be 1. So x0, y would be 1. When x is 1, 2 times 1 is 2 plus 1 would be 3. When x is 1, y would be 3. Okay, y would be 3. I put it too high, maybe. When x is negative 1, for example, 2 times negative 1 is negative 1 plus 1 give us negative 1. When x is 1, y would be negative 1, and this is the other point right here. So if I try to connect those dots, you understand it's going to be parallel to the first one. I mean, it's really parallel, even though you don't see it here, but definitely it's going to be parallel. So this graph right here is g of x equal 2x plus 1. And the other graph right here is f of x equal to x. You see, they have the same slope. That means they go to the same directions, all right? Same direction. Both graphs rise from left to right, okay? And they go indefinitely. So the domain and range would be all real numbers because there is no restriction for this. Now, other things we can use to graph a functions is the intercept. So we talked about intercept. We briefly introduced intercepts in the first sections. Now let's talk about intercepts here instead. We said that, you know, the graph of this particular graph, that was an example because we want to show you why we would use the intercept to graph any linear function because we only need 2 points and it's very easy to use the intercept. Let's say the graph of y equals 4x minus 8. That means if x is 0, remember we're going to find y-intercept. So 4 times 0 is 0. It's going to give you negative 8. So you have a point 0, negative 8. That's the y-intercept. So y-intercept, remember y-intercept means x is 0. But if y is 0, remember you're going to have 0 equal 4x minus 8. So you're going to have 8 equal 4x divided by 4 both sides. So x would be equal to 2. Now you have another point, 2, 0. That's the x-intercept. Okay, so this is right here, x-intercept. And y-intercept would be negative. So we need these two to graph, but know that if you choose another point like x equal 1, if x is 1, 4 times 1 is 4 minus 8 is negative 4. That means if x is 1, okay, we know y would be negative 4. So of course, it may not be done correctly because 1 is right there. Negative 4 would be here. You see 1 right there, negative 4. All right. So tell you, notice that this graph crosses the y-axis at the point 0, negative 8. This point is called y-intercept. Likewise, the graph crosses the x-axis at 2, 0. This one is called the x-intercept. So we have two intercepts, and for any linear functions, it's very giantly easy to graph the linear functions once you know the intercepts. So now, how are we going to proceed with intercepts? In general, to find the y-intercepts of the graph of the equations, not in the form y equal mx plus b, you let x equal to 0, okay? And to find the x-intercept, you let y equal to 0. That's the same thing you're gonna do. So notice that the y-intercept of the graph of y equal g of x, I mean, g of x equal 4x on the previous slide is 0, negative 8. In general, as I said, if a linear function is written in the form f of x equal mx plus b or y equal mx plus b, the y-intercept is b. Okay, we already know it. So for example, you see this one right there, because you have y equal 4x minus 8. You see minus 8 is already your y-intercept. Now, this is a question they ask us to do right there in these examples. Examples 1, they ask you find the y-intercept of the graph of each equation. Y-intercept means x is 0. So if you have negative 2 times negative 2.1 times 0 plus 3.6, remember this term right here is 0. So 0 plus 3.6 is 3.6, right? So you can conclude the y-intercept, I mean, remember x is 0, right? So the y-intercept is 0, 3.6. That's a point. And for the other one, look at this one. If you just said x equal to 0, then you're going to have negative 5 times 0 minus 1/3. So negative 5 times 0 is 0, minus 1/3 is negative 1/3. So again, the y-intercept here is, remember, x is 0. And if you say y-intercept, meaning you have something for y, but I mean, you have a non-zero value for y and 0 for x. That's what it means, okay? Now, we said finding y-intercept and x-intercept. To find y and x-intercept, we let y equal to 0. We keep saying that, and we solve for x. And to find the y-intercept, we let x equals to 0, and we solve for y. Okay, this is if functions where we don't have the regular format where you have y equal mx plus b, all right? To say, oh, b is the y-intercept. Here we have x minus 3y equal 4. I can leave it like this, but they ask us to find the x-intercept. You know, if we find the x-intercept here, x-intercept means, y is 0. So we're going to have x times 3 times 0 equal 4. X equal minus 0 equal 4. X would be equal to 4. Remember, the first coordinate is x. The second coordinate is y. We have our x intercept. Y-intercept, remember, x is 0. So that means I have 0 minus 3y equal 4, negative 3y equal 4. Divide both sides by negative 3. We know y would be negative 4/3. So again, the point we have here, remember, x is 0, so y is negative 4/3. That you can, it will be between negative 1 and negative 2. What they ask us to do now is to plot the points, I mean, graph it. When x is 1, 2, 3, and 4, y is 0. We have our first point 4 here. And when x is 0, y is 1, 2, so 4/3 would be somewhere here. This is negative 4/3, negative 1, negative 2. So connect those dots, because once we do that, we must graph. We must graph because they ask us plot it, right? That's what they ask us to do. The first step we do is to find the x-intercept. We set y equal to 0, okay? And then we find the y-intercept. We set x equal to 0. Okay, now we have our 2 points. Well, we don't need some other points. If you want to, you can find other points. Like, let's say, for example, if you plug y equal 1. See, if you plug y equal 1, we're going to have y equal 1 right there. We're going to have x minus 3 times 1 equal 4. X minus 3 equal 4. If we add 3 to both sides, x would be equal to 7. So when we can have a point again, 7, 1. So meaning when x is 5, 6, and 7, y would be 1. So that's why you see this graph gonna go, okay, definitely that's terribly terrible, right? I'm gonna use it like this. Okay, I'm pretty sure you can do way better than me using your ruler because my pencil right there is terribly terrible. So, we plot the point, the intercepts and the other 0.71. So the graph of 4 equal x minus 3y is a line, right? We know it was going to be a line, but you can continue to graphing as many as possible. For example, here, where they ask you to graph, because I prefer to write it 2x like this. Now, remember we said if you have y equal ax plus b is the intercept. As you can see here, there is no plus something. That means the y-intercept is 0. We have a point 0, 0. So we know um, by graphing these two, our first point will go here because if x is 0, you're going to have y equal 2 times 0. That will be 0. So we have that point 0, 0 going through the 0. Now, our problem with this one, to find the y-intercept with that x equal to 0, so the y-intercept is 0, 0. In the same, if we said y equal to 0, we know 2x equal to 0 if we divide by 2 from both sides. So we know x would be 0. So that means you have another point 0, 0. As you can see, x-intercept is 0, 0, and y-intercept is 0, 0, right? Now, it's not enough to graph because the only point you have is 1.00. And to graph a very straight line, which is a linear functions, you need at least 2 points. So we're going to find another one. If we set x equal 2, then y would be 2 times 2. That's 4. So we have a point 2, 4. When x is 1 and 2, y would be 1, 2, 3, and 4. So then we can graph. Our graph rise from left to right. It's very important. I keep saying rise or falls from left to right because we're going to need it in section 3.4. So that's why I keep telling you it's rise from left to right. So, notice that anytime 0, 0 is a point of the graph, then it is an x-intercept and a y-intercept, right? Why? It is the only point that lies on both axes. So since we need at least 2 points to graph a line, so that's why we try to find another one by setting x equal to 2. So we do that because we have more than 1 point. If you want, you can choose another one. If x is 1, then y is 2, you see? If x is 1, y is 2, right? Right there also, you can see that. You can say 1, 2 as another point because x is 1, 2 times 1 is 2, okay? So easy to graph a linear one. Graphing vertical and horizontal line, that's something else. If you only have to graph x equal -3, it's x -2, -1, -2, -3. All you need to do is do a vertical line on the x-axis. This is x equal -3. Remember, the x-axis is the horizontal axis, the y-axis is the vertical axis. But here, that's what they ask you to graph. Only x equal -2. Why? If you try to construct a table with x and y, right? If x is -3, there is no y. Y is 0. If x is, you know, if anyway, x would always be negative. If y is 10, x would be negative. If y is 5, -3. If y is -5, -3, no matter what you do. Now, the same if they ask you to graph. If they ask you to graph something different, let's say, for example, if they ask you to graph y equal 2, right? If you have to graph y equal 2, the first thing to do is to construct your xy plane, what we call Cartesian plane, and where its intersect is 0, you identify 3 on the y-axis, 1, 2, and 3. Once you do that, then you can graph. As you can see, y equal 3 is a horizontal line because it's intersect with the y-axis. This is the graph for y equal 3. All right. To finish this section, we can summarize about the vertical and horizontal lines. Vertical lines, the graph of x equals c, where c is a real number, is a vertical line with intercept C0. Okay, so you always have a vertical line when x equals a number. When we say C, C is just a number. And horizontal lines is when you don't have x, you only have y equals C, then you will consider it as you will consider it as a horizontal line. So hopefully this help you to understand, and of course you can put the test, the homework of this week with no problem. You can complete it. I'll see you in a different video to go especially over the slope of a line. Let me know if you have any questions. I'll see you soon. Take care.